Hi, welcome to Lesson 20D, Boxplots. The goal of today's lesson is to learn the pure beauty and power that boxplots demonstrate. Basically, a boxplot is what you might have also heard of as a box and whisker plot. It's a way of visualizing the 5-number summary. And that 5-number summary is what we saw yesterday when we were looking at the one variable statistics, when we were looking at our frequency list, sorry, not the frequency list, list 1, and we saw the X bar, the mean, etc. So the 5-number summary it shows us the minimum value, the maximum value, the lower quartile, the upper quartile, and the median. And the box and whisker plot, or the box plot, shows this visually. Okay, so I'll show you how this works, basically. So if we're looking at the 5-number summary, here's a little visualization of that. The one end of the box, the lower end of the box, is the lower quartile. The upper end of the box is the upper quartile, or Q3. The median is at Q2, which is right in the middle here. And the lowest observation, the actual lowest value that is in the list of data, is at the lower end of the whisker. And the upper whisker, the far end, is the highest observation. Now these lowest and higher observations, of course, are only when we're not dealing with outliers. If we are looking at outliers, then we have to do a little bit of little calculation to see if those outliers land in here or not. Okay, so let's take a look here at the little samples here. If we have a distribution that's fairly proportional, fairly standard, we see that here's the box and whisker plot here, the box plot, where the median's in the middle, the lower quartile, the upper quartile are on the two sides of the box, and then the whiskers are spread out to the lowest and the highest observations. That's when the the distribution is symmetrical. If there's a positively skewed distribution where the right side is being skewed and pulled, again, the lower quartile and upper quartile are indicated by the left side and right side of the box respectively. The lowest observation is on the left whisker. The highest observation is on the right whisker. And the median was going to be a little bit to the left inside the box, because just a few values are being stretched higher, meaning that the mean would be a little bit more to the right, but the median value, the middle of all the data, is going to be shifted over to a little bit to the left of the box. And if it's left skewed, if the left side is being pulled by extraordinarily low values in this case, then the lower whisker is going to be longer, upper whisker is going to be shorter, and then the median is going to be a little bit further to the right inside the box. And then the upper and lower, or the first and third quartiles, are the edges of the box there. Okay, so the one thing that I did mention before is the word outlier. And what we would do is, if we happen to have large values or small values, we want to sort of see if these large values or small values are actually outliers or not. So what we're going to do is we're going to do a check. So before we actually draw the box plot, we want to check to see if any of the values are outliers by looking at what's called the upper boundary or the lower boundary. And the upper boundary, what we're going to be doing is we're going to take the upper quartile, so that would be Q3, the upper quartile, then we're going to be adding to the upper quartile 1.5 multiplied by the interquartile range. If there's any data that's larger than this value that we calculate here, that's going to be an outlier. For the lower boundary, we're going to take Q1, the lower quartile, and we're going to subtract 1.5 times the interquartile range. And that will tell us if there's any data values less than that calculation. That will tell us if that's an outlier on the low end. So basically, the reason why we're using 1.5 and 1.5 of the interquartile range is because I'm going to skip ahead a little bit, but when we get into the normal distribution in about 4 chapters, the normal distribution then gets divided up into there would be the median here, and it gets divided up into sets of deviations, and that tells us how much the data deviates from the mean. If it's normal distribution, then the mean's right in the middle. And so if we look at one deviation to the right and one deviation from the left, or to the left, that gives us 68% roughly of all the data within one deviation of the mean. When we look at the interquartile range, remember that the interquartile range is calculated by Q3 minus Q1. And that is telling us where 50%, the inner 50% of the data is, or the 50% closest to the mean, or the median. So we're looking at 50% when we're talking about interquartile range. But when we look at deviations, standard deviations, we're looking at 68%. So if we were looking at 1.5 multiplied by the interquartile range, that would basically be telling us roughly 3 deviations from the mean. So of all in this normal distribution, from here to here, that's about 1.5 of the interquartile range. And so if we do, that would be on the plus side, and this would be on the minus side. We do the same thing. There's another 1.5 in the interquartile range. That then covers the majority of all the data, leaving us maybe 1% at the top that's not covered and 1% at the bottom not covered. So that tells us if any value is 1.5 interquartile range is above the Q3, then that tells us that we've got about 1% of the of data that may be an outlier, and that at the top end of the data. And if we take that same amount below the lower quartile, we've got about 1% that's an outlier below. So we're only looking for those really, really extreme values of 1%. So that's why they chose 1.5 as opposed to just one interquartile range, added or subtracted, or even 2 interquartile ranges. So if we just had 1 times the interquartile range, then we're looking at less of the data above and below the mean or the median of all the data. So that would mean there would be a lot more outliers if it was just 1 times the IQR. So we'd have a lot more outliers. If we use 2 times the IQR, then we're covering a lot more of the data in the distribution, so there'd be far less outliers, like almost none at all. So that's why we had to settle with 1.5, which is a nice compromise between 1 and 2. Okay, and that just leaves us then with 1% of the data that could be an outlier at the top or the bottom of the distribution. Okay, so that's why 1.5 is used. So when you get a list of data, what we're going to do is we're going to first of all test. We'll find the Q3 and Q1, we'll find the IQR, we'll do this calculation here, and actually what a good idea would be is to write this in the list of data itself. Maybe with a different color, or highlight it, or put that number in the list. And then do the same thing for the lower boundary, and put that in the list, and if there's any values that are above or below those values, then we know those are the outliers. And if that's the case, if you do have an outlier, then what you're going to do, even if it's the highest observation, but it's an outlier, what's actually going to happen is the next highest observation will be the actual end of the whisker. So we can say maybe the next highest, and then the highest observation, if by using this test we get that it's above the upper boundary, then we use an asterisk, and that will show us that it's an outlier. Same thing goes down in the lower observation. If the lowest observation happens to be an outlier, by using the lower boundary check, then we use an asterisk to show that, and then the end of the whisker would be the next lowest observation, as opposed to the absolute lowest. So that's about it for box and whisker plots. So what I'd like you to do, please, is take a look at page 522 and 523. Look at example 9 and 10, and play the self-tutor so you can listen to the explanation for the solutions. And then take a look from page 523 to 526, the questions that are going to appear right about now. And take a look at a few of those. You can maybe do a few if you wish. Otherwise, you will have time in class to ask questions and work on the homework or the practice of your new skills in class tomorrow. So thanks for watching, and we'll see you in class.